we can move on to the next presentation from Turkey. Yes, is she here? Nejan Huvaj. Sorry for the presentation. Yes, so you will present your research on rainfall-triggered landslides in northeastern Turkey. Well, very good. So I think go ahead. Nejan, yes, you can start.
Okay. Can you hear me?
Yes.
Okay. Good evening, everyone. Thank you for staying this late this evening. I'm very happy to be part of this event. Thank you for including me. Happy Women's Day to everyone in the audience. Now, today I will talk about rainfall-triggered landslides in Turkey. What I want to convey to you today is a general overview of these landslides, what questions we are trying to answer, what methods we are using, and some results. Of course, it may not be as detailed as we wish in a short time, but we will see some glimpse of the results. The broad pictures, broad questions we are interested in are these. Can we predict these landslides? Where do they occur? When do they occur? Is early warning possible so we can save lives? Can we change the land use planning to prevent these events to become disasters later on? What methods we are using? We are using all sorts of methods available to us. Field investigations. We do landslide inventories using satellite imaging, airborne investigations. We use geographic information systems to evaluate susceptibility and risk assessments. We do soil sampling, laboratory testing to understand the characteristics of these materials, and laboratory model scale physical tests that I will show today a little bit, and numerical simulations. The location that I will take you today is in the northern eastern part of Turkey, a city called Rize. Istanbul, probably some of you are familiar, Istanbul is located here. I am located in Ankara, in the Technical University, and there is the city of Rize, northern part. Why do we study Rize? Because we have these landslides occurring very frequently in the city of Rize. This is a map of Turkey showing a slope gradient, the steepest slopes combined with highest annual rainfall together. The darker reddish areas you see in the northeastern part of Turkey gets a lot of rainfall, and they have steep slopes in this region. So combination of these cause a lot of landslides. Each black dot you see on the map is a fatal landslide event where people have died. So that's why one of the areas we wanted to study is Rize. Some pictures of these landslide events throughout the history from 1970s, where people kept records of these events. Every year 1 to 32 people die if you average them over the years. There is an annual casualty, so it's a significant result. This picture is from an event on August 2010, where after a heavy rainfall, this flow event took place, and even this damaged a building, causing 13 casualties, 174 destroyed houses. Some repairs are needed, a lot of significant infrastructure damages, roads, etc., and farmlands are damaged. Another picture in the lower part in this image. The rainfall is extreme. The day before the disaster event, it was about 166 millimeter. On the day of the disaster, 52. So combination of these within the 2 days time, they got average more than the average August monthly rainfall within just 2 days. And also the city of Rize in general gets significantly high rainfall. Like the Turkey's average annual rainfall is about 574 millimeter per year. And average annual rainfall in this city is already very high. And among that, within this 2 days, they got significant rainfall. So some pictures from the damages you see on the screen is there are these steep slopes where people have houses, roads, and farmlands. This vegetation you see on the slopes is tea plantation, black tea, where people highly, overall this area, they grow tea plantation. They get their farmlands are damaged, roads and houses gets damaged, and other pictures of the damage to structures. And another aerial view where all the brownish areas you see on the figure is landslides, greenish areas is not landslide area. And even a broader look from above, after a significant rainfall event, we get many of these landslides. And another picture. Now I will take you to a short video, if this works properly. So this is a drone fly over after one of the events in Yeşiltepe village in the city of Rize, where we see again this brownish colored landslide areas in tea planted sites. And there are people living on the, you see the houses and roads, and very shallowly looking landslide events. The mechanism, what are the mechanisms that control these events? Originally, we have a slope that has a groundwater table, let's say, way below the ground surface, and there is an initial existing suction. We can call this negative pore water pressure between the particles, soil particles, and there is an existing shear strength in this condition. When we get rainfall events, with certain time you get an intensity of rainfall event. This infiltrates into the soil, reduces the existing suction and existing shear strength. So shear strength of the soil material reduces. Then this leads to a failure event. So we can say factor of safety drops with time as the rainfall infiltrates and progresses. I was happy to listen to the previous talks, Claudia and Noreen. Thank you for the matching topics. I was very interested in their works. What we are trying to see is, can we numerically model this rainfall infiltration into the material? Can we predict the triggering of the landslide event? So for these purposes, we want to know the typical depth. Are they 1 meter, 5 meter, typical depth of these landslides? Their aerial distribution, relation to vegetation cover. They look like they occur a lot in the tea planted areas. Do they occur on the forest cover? Their relation to slope angle, at what angles we may get these? Elevation, does it have any relation? Do they occur like a translational movement or circular type movement? And you can see some examples here. You have a failure in a circular mode or slipping like a planar mode. And we are interested in identifying these. What are the runout distances and what are their geometrical cross-section along the length and along the width of the landslide? So if I take a cross-section, do we see like a V-shaped valley kind of movements or other kinds of geometries? So that when we do analysis, we want to investigate maybe 2D, 3D mechanisms and so on. So we looked into these landslides. One example here you see is again tea plantation. Their roots of the tea is about 50 centimeter. So we see a little bit deeper than that and a large area on a steep slope. For scale, you see me on the slope. This is 1.67 meters. And this depth of the landslide is, let's say, 2.53 meters or so in this example. We see very shallow flow kind of versions, less than 50 centimeter, very shallow examples as well. And we see that these landslides occur mostly about tea planted areas, but they also occur in forested areas. On the left picture, we see another version of these landslides after a rainfall event on the forested. And on the right, we see tea planted region. So other versions like the circular failures are available. So what are the typical characteristics? We wanted to identify. They are generally shallow, maximum 5 meters depth, typically 2 to 3 meters depth. They occur on steep slopes. They are classified as fast landslides. They occur very fast during this rainfall event. Then groundwater table does not exist on the surface. It is way below. The material is initially unsaturated. These are residual soils made by weathering of rock in place. These rocks are volcanic origin, pyroclastics. And they are silty soils in the end, we discovered. Mostly translational, but some of the movements are rotational in a sense. But how about these properties of these soils? Over the years, since 1970s, these landslides have been recorded. People die and damages are occurring, but nobody knows. They call our clays and our soils, but nobody knows the details of these soils. So we took a study with one of my master thesis students, Mr. Emre Üyetürk. He's now in the United States doing PhD. His topic was geotechnical characterization of these soils in Rize. What are their physical, mechanical properties? Because we wanted to know the material so that future work may do numerical modeling. You can do stabilization works, susceptibility mapping, or these intensity duration thresholds. Everything depends on what are these materials, their characteristics. We prepared a paper in Engineering Geology Journal. If anyone is interested, please email to me and I can send this to you if you're interested. And another paper on the drying effect on the laboratory testing of these materials. We took a fieldwork and laboratory work, visited 12 different landslide sites after rainfall events. We took soil samples and we did some in situ testing. This is the location of the landslides events that we visited. And on a digital elevation map, these are located in shallower regions where the landslides occur. Coming to the geology, these are, as we said, residual soils made by weathering products of tertiary alkaline, volcanic pyroclastic rocks, basaltic andesitic characteristics, and also the environment and humid climate in the region that promotes intense chemical weathering of these materials. We have different examples from different in our 12 landslide sites, different geology. Some of our sampling sites, we went to take soil samples and investigate the shear strength. We see the landslide head scarp, we inserted some small tubes, and we did some hand vein tests, in situ shear strength measurements, and so on. Some other pictures from the fieldwork, and here's the lower picture is, as you see, many men and me investigating these landslides at site. Villagers are very helpful and they are hospitable. They were giving us tea that they grow on these slopes. So the laboratory work we carried out included many examples of laboratory tests. We wanted to look at their conductivity, shear strength, and classification of these soils, and so on. It looks like they are mostly fine-grained, silty soils, low plasticity, high plasticity, silty materials. They have some organic contents and they are acidic. The reason why we looked into the acidicity of the material is some people were arguing that a lot of fertilizers over the years, 50 years time, every time they are putting more fertilizers, that may change the characteristics of the material. So we wanted to look into that. This is a plasticity chart where we see these are more silty soils in this region. So these are all different from 12 different landslide sites, and they are similar materials. One thing we noted in the laboratory, if any of you are interested, when you dry these materials in the oven to do some testing, their properties change dramatically. So we have to be careful. If you don't dry, when you bring from the site in a moist condition, you do the test and liquid limit is 87. When you put into the oven to make things faster and dry it in the oven, you get a completely different result. So drying has significant effect even on the soil classification of these materials, and we have to be careful. They contain halloysite mineral in their mineralogy. We did X-ray diffraction and scanning electron microscopy studies, then looked into the minerals making these materials. We did in the laboratory unconfined compression tests. These are some of the testing that we checked the strength of the material. We checked their void ratio, how dense, how loose condition they are. Their sensitivity, when you disturb a little bit, do they lose dramatically their strength, and so on. They are sensitive, extra sensitive materials. So some pictures from our laboratory testing. We did direct shear tests to measure the shear strength in the saturated and unsaturated conditions, because initially they are unsaturated, but when the rainfall enters, they lose their strength. We wanted to capture that behavior and checked at different saturation levels and wanted to see the effect of that. Just a very small figure from the results. This is the strength of the material envelope, shear strength envelope. Black dots are in a saturated condition and white dots are in an unsaturated. So the higher values you see on the white dots say that initially they are stronger materials, and when the rainfall penetrates, they go towards the black line, which is the lower shear strength black dots. The second work I will talk about is the PhD study of my student Mohammed. He wanted to model these in the laboratory in a model test, because in the field there are a lot of variables that you cannot control. So we wanted to see, can we generate these landslides or kind of similar landslides in the laboratory, and can we numerically model and get the same thing in a study? And Claudio was showing some intensity duration thresholds, so I'm going to show something similar. So here is a plot of rainfall duration and on the horizontal axis, and rainfall intensity. If you have an intense rainfall, it would be on the upper part of this graph. Then you would have, for example, landslides. if you have a very small amount of intensity rainfall, but it rains for all days, let's say 2 days, 3 days, 5 days, if you get a long duration, you may trigger landslides maybe. So this figure shows at which rainfall we may get landslide, at which rainfall we may not get landslides. People use these kind of thresholds to identify and do some warning. And Italian colleagues have significant work already done on this, identifying for their country and for the world some threshold values. So we wanted to see, can we determine such threshold values in the laboratory in a controlled environment where I know the material properties, I know the rainfall coming, can I model this numerically? So we conducted some physical model tests. This is a study published in Environmental Earth Sciences where we present our laboratory flume study. Basically, we have a big, like a long aquarium kind of a box where we prepare our soil. And on top of this, we apply a certain amount, known value of rainfall. And we have some instrumentation to check tensiometers to measure the suction, inclinometers to measure deformation in the soil, and see if we can trigger landslides. So this is the box, the bottom of it. We prepare our own created inclinometers to detect the movement of the soil. Some drainage options and some inclinometers are seen here in the middle and on the sides. Then we place our soil. This was a very fine sand or silt category soil that we compact at certain density, known value, and we put our measurement devices to detect the movement and so on. In the end, we prepare to the desired slope angle. And you wait for some equilibration of the soil conditions, and you raise it to the certain angle that you want to study. Well, in this one, the one thing I wanted to say is the landslides that we have seen in this material did not go beyond the depth of the box. So immediately you may say, well, there is this box at the end of the box, you limit the movement, but all of the landslides took place within the upper section of the slope, so we wanted to study in this region. I have a very short, quick movie if this works. So this is Mohammed preparing the soil sample in a very fun, enjoyable way, with the music, let's say, to the certain slope angle. Then we go to equilibration and apply the rainfall and trigger the landslide. So we measure the infiltration of the rainfall into the soil, and we wanted to see, can we simulate the same thing numerically by knowing the material properties. So here is a video our university prepared. So you see the blue line is the penetration of the rainfall into the soil, and we wanted to simulate that right next to it. So we were successful in some majority of the works that you can see the penetration of the rainfall, you can simulate that, and you can trigger a landslide by applying rainfall in the laboratory. And these are our inclinometers that detected the movement depths. And then we were confirming.
Sorry.
Yes?
You have half a minute.
Okay, oh, sure, quickly. So we capture this movement in the laboratory on some example landslides. And in the end, we reach to this kind of a graph, rainfall duration, rainfall intensity. So we prepare these kind of threshold graphs for different density of the soils. And we see that at the very large ends, you may not trigger landslides in a very, very small intensity. Even if you keep it raining for 2 days, 5 days, it doesn't trigger landslides. So these are some of the conclusions I think you can read from the papers if you're interested. In details of our numerical study, I will skip these very quickly and go to the end. So we see that material properties play a critical role when you want to predict these landslides. Intensity duration can be computed if you know the physical properties of the material. Both the high intensity short duration and low intensity long duration rainfalls, if you keep them raining for a long time, can cause landslides. And you can predict these thresholds by analysis. Material properties, the most important property seems like the grain size, which controls some of the unsaturated material properties. And these are some of the other conclusions. I will go to the end. Thank you for listening to me. Okay. I go out from the presentation. Okay. Should I stop sharing? Yeah. Okay. Any questions? I would be happy to answer.
Yes, Nikki, I have one point to know.
Yeah.
I am Sunil from India. Can you hear me?
Yes, yes.
Yes, come on, Sunil. Please go on with your question.
I have a query to Nejan. My specialization belongs to same area almost in Darjeeling Himalayas where tea plantation is a common factor.
Mm-hmm.
My question is that tea bushes, its root are horizontally spreading and it stabilizes the topsoil cover. In your study area, if it is a shallow landslide, is there any barren land from where the rainwater percolates downside? And the landslides can occur?
Well, actually, on the surface, we have tea plantation, but water can go down to the surface of the soil. It doesn't completely block the penetration of the water. So there are ways that water goes in. I didn't see any barren land. All of the surface is covered either by forest, by houses, by roads, or by tea plantation. There didn't seem like a clean soil area only in the region.
How the rainwater percolates downside? That is my question.
It finds a way that from the roots near the surface of the soil, it finds ways to go down, if I understood correctly.
Okay, thank you very much.
Thank you for attention. I see a question in the chat. Carl Wutzer has a question. And he says, thank you in Turkish. Thank you for saying that. Yes, we have a lot of landslides, more frequently in the last years compared to previous decades. Yes, exactly. There is another study we are interested in, especially with climate change. We are interested to see, we get a lot of more extreme events. Like in a very short time, you get intense rainfall. And rainfall is not all over the whole city, but it's localized in one valley, one basin. It focuses just there, it rains. Then you get a lot of rainfall specifically in that region. And we noticed that, yes, in especially recent years, we get more of these events. Yes. Thank you, Claudia. Yes.
Thank you very much for this nice presentation and for answering the question.